Hello people, today I'd like to explain to you one of the most popular algorithms in computer science, greedy algorithm. But first, we have to know what is greedy algorithm. Greedy algorithm follows the inductive process thinking that is making the locally best choice for finding the best overall result. What does this mean? Let's dive into the example to better understanding. The first example is choosing path problem. The greedy algorithm says, at each step of the journey, visit the nearest city. Here, I have a directed graph. We are from home, wanting to go to restaurant. If we look globally, we choose to go via town B because it have less distance compared to A. B is only 10 unit and A is 100 unit. But if we use greedy algorithm, we actually want to choose via town A because at this point, at this current state, there are only two choice between 1 unit or 5 unit, and global algorithm and greedy algorithms always choose the local best for the global optimum. Not a really good choice, but we follow the rule at each step of journey, visit the nearest city. From this we learn, greed is not always good. This is the natural trait for being a short-term visionary rather than a long-term visionary. If it is so bad, then what's the point? I'll tell you the point in the next example. The second example is knapsack problem. The classic knapsack problem is about a thief breaks into a store and wants to fill his knapsack of capacity K with goods of much value as possible. The question is, does there exist a collection of items that fits into his knapsack and whose total value is over or equal W? Because greedy always put the best solution first, we must get the most valuable goods per weight. After we calculate the goods, we will get the most of the valuable. We see the green is only worth $0.33 per kilo. Blue is $1, gray is 2, orange is 1, and yellow is $2.5. We will get the most of the most valuable first. So, we get the 4 kilo of yellow. The second most valuable, the gray, 1 kilo. And if there are two or more items that hold the same value, it doesn't matter what you choose. So I choose first 2 kilo of blue, then 1 kilo of orange, and the rest we fill up with the least valuable goods. That is the green, only 4 kilo, because the max capacity of our knapsack is 15 kilos. Another case that the greedy algorithm is the best is the activity selection problem. In this case, you are given n activities with their start and finish time. Select the maximum number of activities that can be performed by a single person, assuming that a person can only work on a single activity at a time. No multitasking. The greedy choice is to always pick the next activity whose finish time is least among the remaining activities and the start time is more than or equal to the finish time of previous selected activity. These are the steps. First, we always want to choose the first activity, which is activity 2. Then, If there are any overlapping activity, we will eliminate those. For the example, we eliminate activity 3 and 4. Then we choose the next nearest activity, which is activity 5. Because there are no overlapping activity, then we choose the next activity, activity 1. So we got activity 2, 5, and 1. Why does this algorithm always result the best, at least in this problem? Let's see. Let the first activity selected by B be K, which K is any other activity than the first activity. Then there always exists A equal to B minus K union with the activity 1, the first activity. If, for example, B equal to 5 dot dot dot, B minus K is only dot dot dot. Then there always exists A equal dot 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 union 1, which A equal 1 dot dot dot. If we look at this is basically the same set. This is the code implementation of greedy choice work for unsorted activities according to the finish time. First, we declare a struct of set of activity containing string name and start and finish time in integer. Then we have a function to sort these activities based on their finish time. Then the activity selection is the main core of this program. We always want to choose the first activity. Then we calculate the rest. We compare if the next activity has start time greater than or equal to the finish time of previous selected activity. If yes, then we select that activity. I will put the link of this code down in the description if you want to try it for yourself. So, the final question is, does the greedy algorithm always works? Usually yes, but not always. Most of the problems with a wide range of problems can be solved by the global optimal solution, or at least a similar solution to the global optimal solution. Plus, I think with the more advanced processing power, using greedy algorithms can be a little bit forgiven, because there is such a big overhead processing power if we really want to have the fast and simplicity of greedy algorithms. I think that is all. Thank you for your attention and have a good day.